Hello and welcome to this project presentation. My name is Jay Kishore Casey and I am presenting this project on behalf of our team Akil Ahmed RS and Devesh S, students of batch 8 under the guidance of our mentor Mr. K. Srinivasan. Our project is titled An Agentic AI Framework for Persistent Omnichannel Conversational Sales and Autonomous Retail Task Orchestration. This work falls under the domain of artificial intelligence and machine learning. This video walks you through our project from start to finish. Abstract. At our high level, our system is conversational commerce platform powered by agentic AI. The core idea is to bring conversational AI, multi-agent coordination, persistent memory management, and retail workflow automation, all within one unified platform. Rather than a traditional e-commerce site, our system allows customers to interact through natural language, text, or voice across multiple touchpoints while maintaining full conversational continuity across successive interactions. Persistent session handling is achieved using MongoDB Atlas, which stores chat history, customer activity, and workflow context. This allows the system to remember what was discussed in a previous session and seamlessly continue from that point. Backend is built around a fast API based orchestrator that intelligently routes requests to specialized agents, handling recommendation, inventory, payment, fulfillment, loyalty, and support workflows. The front end is built with a React, TypeScript, White, and Tailwind CSS, and conversational AI capabilities are powered by OpenRouter and Gemini. In short, this project demonstrates how persistent conversational AI and autonomous agent orchestration can improve customer engagement optional efficiency in modern omnichannel retail. Problem statement. The problem we are set out to solve is fundamentally about fragmentation in modern retail. Today, customers interact with retail business across multiple channels web, mobile, chat, and in store. However, most of these touchpoints operate independently. When a customer switches from one channel to another, their context, preferences, and shopping intent are lost. They are essentially starting over every time. Additionally, conversational systems in retail are typically siloed. They handle basic queries but have no real integration with actual retail workflows like cart management, order tracking, or inventory. This severely limits the usefulness and personalization quality. Our system directly addresses these limitations by building a platform that maintains persistent conversational context and coordinates all retail workflows through a single intelligent multi-agent backend. Introduction. To frame our solution, let us establish three profound concepts that motivate this work. First, the customer journey reality. Modern shoppers interact across many channels and naturally expect a consistent connected experience across all of them. Discontinuity between touchpoints frustrates users and directly reduces conversion. Second, context fragmentation. When retail touchpoints do not share state, customers are forced to repeat preferences and shopping intent across interactions. This is not just inconvenient, it affects customer loyalty and overall shopping satisfaction. Third, conversational AI. The systems that interact with users through natural language, post text, and voice. In retail, this enables product assistance, recommendation, and support, all through dialogue rather than manual navigation. These three concepts form the foundation that we have built. Building on this foundation, we have introduced three more concepts central to our design. Multi-agent systems. Instead of a single monolithic AI handling all tasks, our system uses multiple special agents, each responsible for a focused domain: recommendation, inventory, payment, fulfillment, loyalty, and support. This separation of responsibilities improves both accuracy and maintainability. Omnichannel retail. Our platform is designed to maintain a connected customer experience across different retail touchpoints within a unified system, rather than treating each channel as isolated. Recommendation systems. Integrated conversationally into our platform, these allow our product discovery through natural dialogue rather than through manual search and filter operation. Together, these concepts lead us to our proposed solution, an agentic AI platform where persistent conversation and coordinated agent workflows are deeply integrated, enabling a truly connected retail experience. Literature review. Our literature review is grounded in three key works that directly informed our design. The first by Sun Hoon and Pompili of IEEE 2025 surveys LLM-based multi-agent systems, focusing on how agents coordinate, communicate, and make cooperative decisions. This provided the conceptual framework for our orchestration architecture. Second, by Ma and others of IEEE 2025, introduces transformer-based agent modeling with attention mechanism for adaptive multi-agent interaction. This supports our approach to contextual coordination between specialized agents within retail workflows. Third, by Park and others, the seminal generative AI agents paper demonstrated agents capable of maintaining memory, reflection, and contextual continuity across successive interaction. This directly influenced our persistence and memory management design. The research gap we identify is this. While existing work explores convolutional AI, persistent agent, and multi-agent coordination independently, no system integrates all three within a unified commerce-oriented platform. Our proposed system is designed to fill exactly that gap. Issues and challenges. During the design and implementation of the system, we encountered several insignificant challenges. Conversational continuity was the primary challenge, ensuring that context carried forward meaningfully across separate sessions, not just within a single interaction. Workflow fragmentation. Making sure that conversational layer, recommendation engine, checkout workflow, and order taking all operate cohesively rather than as disconnected components. Multi-agent coordination required careful orchestration. Routing requests to the correct agent based on intent without conflicts or drop context between agents. Workflow integration. Tightly coupling conversational interaction with cart management, checkout assistant, and order workflows so they function as a single seamless experience rather than separate systems. Persistent session handling. Using MongoDB Atlas required designing a data schema that captures not just message history, but the full workflow state of each customer. External AI dependency. Relying on OpenWriter and Gemini API for response generation introduced latency and reliable consideration that had to be addressed in the architecture. Finally, system synchronization. Ensuring consistent and reliable communication between the React frontend and the FastAPI backend services and the MongoDB database layer across all workflows. Having identified these challenges, let us now look at the architecture we designed to address them. This slide presents the overall system architecture of our agentic AI framework. The diagram is organized into 6 distinct layers and walk through each one. Starting from the left, we have client layer. Our platform supports three types of clients: a web application built with TypeScript React, and in-store KR also built on TypeScript React, and a web responsive web interface that adapts to mobile, tablet, and desktop. This established the omnichannel nature of the platform right at the entry point. All client requests pass through the API layer implemented using FastAPI. This layer exposes 6 categories of API: Authentication API for login and registration, Product API for browsing and detail, Cart API for add and update and remove operations, Order API for history and tracking, Chat APIs that power the conversation assistant, and on Voice APIs for the voice assistant interaction channel. These feed into the AI orchestration layer, the intelligence core of the system. The orchestrator works through three internal steps. First, the context builder assembles the user profile, activity history, cart state, and orders into unified context. Then interdiction classifies the user intent using an LLM. And finally, the response composer generates the final response along with action links for the frontend. Below the orchestration sits the specialized agents, each focusing on a specific retail domain. The sales agent for product search and purchase guidance, recommendation for preference-based suggestions, inventory agent for stock availability and ETA, payment agent for transaction handling, fulfillment agent for order and delivery tracking, loyalty agent for points and benefits, and support agent for returns and complaints. These agents interact with the commerce workflow and simulation engine, which manages these three critical operations: the order lifecycle manager transition order through creation, packaging, shipping, delivery, and return states. The payment simulation module handles success, pending, and failed payment scenarios, including refunds and retries. An event and notification engine triggers email and SMS notification and schedule follow-up reminders. At the base sits the data layer, MongoDB Atlas, and 7 dedicated collections: user products, card orders, payments, chat sessions, and activity logs. Each layer in the system reads from writes to the database. This slide zooms onto the agent requesting routing workflow, showing precisely how a user query travels from input to response. The top of the diagram shows a clear 7-step linear flow. Step 1 is user input. The user sends a query via chat or voice. Step 2 is pre-processing. System normalizes the input in exact context such as session history, entities, and current state. Step 3 is intent detection. An LLM classifies the query's intent. Step 4 is agent selection. The directory intent is mapped to most suitable specialized agent. Step 5 is agent execution. Specialized agent processes the request and performs its task. Step 6 is response generation. Orchestrates to compose the final response. Step 7 is response delivery. The response is delivered to the user using the same channel used, maintaining channel consistency. The detailed flow diagram below illustrates the internal mechanics. The user interface on the left accepts input from either touch or chat channels, web or kiosk, or from voice input channel. Inside the AI orchestrator, four components work in sequence. The input processor and context builder cleans the input, extract entities, and builds a context object from the user's profile history and session state. This moves to interdiction, which uses an LLM classify the intent and determine the task type. The agent router then manages the intent against the capabilities of the specialized agent and selects the best fitting agent. The task dispatcher formats and forwards the router request to that agent. Once the specialized agent completes his task, request flows into context and memory store, which updates in conversation history and stores the outcome for future sessions. The response composer, again powered by an LLM, synthesizes the agent output in a coherent natural language response delivered it back to the user interface. Throughout the entire flow, the MongoDB Atlas data layers access for read and writes, keeping all 7 collections current and consistent. This workflow is what makes our system genuinely intelligent and stateful. Every response is grouped and grounded in context, routed precisely, and composed coherently before delivery. System requirement tools. For hardware, the system runs on Intel Core i5 or Ryzen 5 or higher processor, with a minimum of 8 GB RAM and 20 GB storage, allowing a stable internet connection for API communication with external AI services. For the context, the software stack used across the project includes Python with Fast API for backend, MongoDB Atlas for the database, React with TypeScript, Byte Daily CSS for frontend, and OpenAuto and Gemini for conversational AI capabilities. These are all well supported production capable technologies updated for a project of this scope. Module, FastAPI Orchestrator and Multi-Agent System. The first major module is the FastAPI Orchestrator and Multi-Agent System, the processing core of our backend. The user sends a conversational message, the orchestrator receives it and forms intent analysis. Based on the detected intent, it determines which special agent or combination of agents need to be revoked. For example, if a customer asks, what is the status of my latest order? Orchestrator recognizes this as a fulfillment query and routes it directly to the fulfillment agent. Orchestrator also handles multi-agent coordination in case where a request spans multiple domains such as checking stock availability while adding a product to cart. It coordinates between the relevant agents and assembles a unified coherent response. Critically, this model handles conversational response generation by integrating with the AI services, ensuring that every reply is contextually appropriate, detail focused, natural sounding rather than raw data. This is what makes the system genuinely agentic, intelligent and context-aware routing and response, not predefined scripted disciplines. Module Memory and Context Management System. The second is the Memory and Context Management System, responsible for giving the platform its persistent stateful nature. Every interaction a customer has is stored in MongoDB Atlas, including full message history, card state, active order, and customer activity logs. When a new interaction begins, this module retrieves the relevant content and injects it into the orchestration workflow, enabling seamless conversational continuity across sessions. Illustrate if a customer was asking about running shoes last week and returns to page, system recalls the context contains naturally, without the customer needing to repeat themselves. This module also tracks workflow state, meaning if a customer was made checkout in the conversation, system will receive more on less than restarting the entire flow. Together, orchestration and memory system form the backbone of the platform's intelligence and continuity. One routes intelligently, the other remembers persistently. These are implementing screenshots. The front-end home interface. Moving to implementation, this slide shows the front-end home interface. Built with React TypeScript integration, interface responds quickly. Customers can browse products, navigate across categories, and initiate conversational interaction directly from this view. The design keeps the conversation accessible to all times, making it a natural part of the shopping experience rather than a separate feature. This slide demonstrates the conversational chat interface, the primary interaction point of our platform. Customers can type natural language queries. The system responds with contextually relevant retail-focused replies. The interface supports multi-turn conversation. Each response is informed by its full session history. This is where the memory module and the orchestrator work together in real time to deliver coherent, personalized retail assistant experience. This screen shows the product catalog view. Customers can browse products, apply filters, and view product details. The catalog is tightly integrated with the conversation. A customer can ask the assistant to show me running shoes under 3,000 rupees and system in surfaces relevant products directly within the conversation alongside the standard catalog navigation. Cart and wishlist workflows are also accessible from this interface. This slide shows the checkout workflow output. Once a customer is ready to purchase, the system coordinates the checkout process through the payment agent. The interface handles order generation, orchestrates, ensures the card data and customer contacts are correctly passed through the payment and order workflows. This demonstrates the practical end-to-end integration between conversation assistant and actual commerce operations. Implementation screenshot. Order tracking shows the order tracking interface, which displays the full lifecycle of a placed order from processing through packaging, shipping, and delivery. The fulfillment agent powers the view. Importantly, this information is also accessible conversationally. A customer can simply ask, "Where's my order?" in the chat. The system retrieves and presents the current fulfillment statement through natural language. This round trip from conversational query to backend agent to database to composed response illustrates the complete end-to-end capability of the platform in action. Our work is grounded in a strong set of academic and technical references spanning publication by IEEE ACM, covering multi-agent systems, generative agents, retrieval augmentation, task-oriented dialogue system, and omnichannel retail. These references provide the theoretical and empirical foundation for our design decision made throughout these projects. To summarize, this project is a working implementation of an Agent KI retail platform that integrates persistent and conversational interaction, an autonomous multi-agent workflow orchestration, and end-to-end commerce workflow handling with a single unified system. We believe this represents a meaningful contribution towards intelligent, context-aware, and truly omnichannel retail experiences. Thank you for